This component is known as the negative pressure relief vent. This particular vent opens when the cabin pressure is less than the ambient pressure. This prevents the negative cabin pressure. Too much negative cabin pressure could damage the fuselage structure. So physical description of this particular vent is the negative pressure relief vent is a spring-loaded door. It starts open at a differential pressure of 0.2 psi. It is full open at a differential pressure of 0.5 psi. The thing you see is a static port in the airplane, which uses to measure the static pressure around the fuselage of the airplane, which for critical for sensing the aircraft primary parameters. So this component which you are seeing is just circular, which you see in a circle, the positive pressure relief vent or valve. So this purpose of this valve is opens when the cabin air pressure is higher than ambient pressure. It's actually the opposite of the negative pressure relief valve. It's only two in the airplane on the left side of the fuselage, forward left side. This permits air to go out the airplane to keep it differential pressure below a safe limit. So comes with the physical description. The positive pressure relief valve is a mechanical device. It has an air filter and two ambient pressure sensors connections. The air filter supplies cabin pressure to the valve. The ambient pressure connections supply ambient pressure to the valve. An internal ambient sense port, as in the base of the valve. The vent or the hole you can see in the fuselage next to the positive pressure relief valve is the vent, smoke vent. It is used for venting the smoke from the forward E&D compartment. The component you can see is a outflow valve. The outflow valve in the Boeing 777 is a very crucial component of the aircraft pressurization system. It regulates the cabin pressure by controlling the outflow of the air from the cabin to maintain a comfortable and safe environment for the passengers and crew. The key functions are the cabin pressure control, adjusts the cabin altitude by modulating the air outflow of the fuselage. The fuselage now the seams the top one is the angle of attack prop, angle of attack sensor. The next one down to the angle of attack sensor is the TAT prop, also known as total air temperature prop. The next one is the ISTT prop, and next to that is the pitot prop. The component which you see is, let me say, radome. In the Boeing 777, the radome is made up of the carbon fiber honeycomb structure composite material. Inside the radome, there are special antennas which are the weather radar antenna, glide scope antenna, and localizer antenna. Three antennas are inside the radome. You have to make sure the radome is not damaged, there is no dent or any kind of abnormalities, or if there is any, the latches are properly secured and fastened. So the black dot you can see is a camera which is used to guide the pilots while during the maneuvering on aircrafts on the ground. Can especially help the pilots during the taxi procedures. And next to it, it is a access panel, or you can access door. So, ladies and gentlemen, you can see the wire-like thing, which you can see is actually it's an antenna. It is called glides slope track antenna, which is on the leading edge of the left and right aft nose gear doors. The particular location when we see is the left hand center is on the left aft nose gear door, and the right one is on the right aft nose gear door. When you see the purpose of this particular antennas is to supply final approach and landing glide stop signals. The track antennas are in a position to minimize the vertical distance between the antenna flight path and the main landing gear. Board which you can see is in the airplane in the forward fuselage on the right side, which is called the which we actually connects the external power. When the engines are off, the APU is off, we supply the aircraft with the external power. It has two ports, 2 and 1. The 2 is the primary one and 1 is the secondary one. So that's it. So over the years, a lot of people asked what are the 4 squares as well as squares on the the sensors. So actually, it's a very important area in the airplane structure. It is known as a RVSM critical area. So it's a RVSM means the reduced vertical separation minima. It basically allows the airplanes to fly in a level altitude closer to each other. Now, in order to guarantee that this particular system work as designed, as several points needs to be satisfied. One of them which is the integrity of the static port, which I mentioned earlier. The static ports can be sensitive to the external airflow, and hence any variation or disturbance, abnormality in the area immediately adjacent to them on the fuselage must be avoided whatever or whenever you want to use aircraft for RVSM operations, and hence the markings to be serve as a guide to all involved in aircraft operations about which is the area to be worried about. Example, any imperfection in that area will or the region will have to be dealt with immediately, and in worst case the aircraft would not be able to capable of flying in the RVSM operations till any problem fixed.